Hey everybody, it's me, Mr. Cox again, and today's lesson is going to be about naming acids and bases. So what you're going to do is while I'm going through this screencast video, you can take notes on your own PowerPoint like this, or you can just watch the video and then you can fill it in later. I've given you a link to the filled in version. So the first thing I want to talk about is the history of acids and bases. So the first thing that people back in the day, like the 1800s, they thought that oxygen actually caused things to be acidic. And you know what acidic is. If you've ever, like, you have a cut and then you get some lemon juice in it and it really burns. Lemon juice is actually an acid. Some other things that are acids are things like soda. Soda has this thing in it called phosphoric acid, if it's like a dark colored soda, or if it's a light colored soda like Sprite, then it's going to have citric acid in it. It also has carbonic acid in it from all the carbon dioxide that's dissolved in it. So back in the day, people thought oxygen was responsible for acidic properties, and this guy named Humphrey Davy, he actually showed that oxygen is actually not responsible for acidity. And the way that he did that is he had a ton of different compounds that had oxygen in them, and he showed that not all of them were acidic or made the pH of a solution go down. And I'll talk about pH more tomorrow. All right, then the next guy, he's a German chemist, his name is Justus von Liebig. He actually showed that hydrogen, whenever you had a compound that contained hydrogen, like as the very first element in it, that was responsible for acidity. So what he did was he took a ton of chemicals or compounds that had H at the very beginning, like HCl or HF or HO2 or something like that, and he showed that all of those caused the pH to go down and all of those had acidic properties. So then in the late 1890s, they finally came up with a definition for an acid, and this guy, his name is Svante Arrhenius. He says that acids are substances that add hydrogen cations or hydrogen ions to solution. So a cation, remember, cations are always positive. You get the joke. Okay, let's go on to the next slide. So how do I recognize an acid? So if you were to see an acid in, a chemical formula for an acid, what would it look like? Most of the time, or about 98% of the time, it's going to start with H, or it's going to start with hydrogen. And acids are sour. So if you like things like Sour Patch Kids, or the Sour Patch Straws, or all those other different things like Sour Skittles, then you probably know what I'm talking about. One of the main ingredients is this thing called oxalic acid, which is actually derived from a plant, and it makes things acidic or sour. So lemon juice is also an acid. Like I said earlier, soda is an acid. There's tons of stuff that are acids. So acids, they are also going to react with group 1 and 2 metals. So things like, let's see, magnesium or sodium, potassium, calcium, strontium, all those that are in the first two columns, they react with acids to form hydrogen gas. And hydrogen gas is extremely reactive. If you're curious about that, you can look up the Hindenburg, which is when they filled a giant blimp with hydrogen gas and then one small spark caused it to explode. Acids react with bases. So bases are kind of the opposite of acids, and they produce salts and water, and more on that later. Acids also conduct electricity when you dissolve them in water, which is why you may have seen people, they use a lemon as a battery or something, because the acid cations and then the anions, they conduct electricity. All right, so let's talk about the two different types of acids. So the first one is called a binary acid with the prefix bi meaning two. So if there are two capital letters in the chemical formula and the first one is H, then you know that you've got a binary acid because the binary acid has two capital letters, and since it's an acid, it has to have H at the beginning. So to name these, if they give you the chemical formula for them, what you're going to do is you're going to add the prefix hydro to the front, like the first part of hydrogen. So you're going to have hydro at the front, and then you're going to find the root of whatever that element is. So for example, in this first one here, we've got hydrobrome, because bromine, the root for that word is, or root for that element is brome. Remember when we named all those compounds and we had all those different roots, like chlorines is chlor, fluorines is fluor, iodines is iode. So there's a ton of different ones, and you could probably have them memorized. So then after that, you're going to add ic, and then you're going to put acid after it. So in this first example here, we've got HBr, and there are two capital letters, the H and the B, and the first one is an H, and so we know that that is going to be an acid. So since there's only two capital letters and the first one is an H, we're going to add hydro to the front, then we're going to add the root of that element. Since it's bromine, Br, it's going to be brome. Then we're going to add ic to the end and add acid after that. So this is hydrobromic acid. Okay? Next one, HCl. So there's an H here, so that's at the beginning. We know that it's an acid. And then there's Cl. All right, so there's only two capital letters here. The first one is an H. So we're going to add hydro to the front, then chlor, because that's the root for chlorine, chlor. Then we're going to add ic, and then acid. So HCl is actually hydrochloric acid. And you may have heard of hydrochloric acid before. Some people call it muriatic acid if you're using it at a, like an Ace Hardware or somewhere like that. Then you'll probably call it muriatic acid. Okay, so let's talk about the next one. Let's talk about these things called oxyacids. So the first one is called binary acids. The second one is called an oxyacid. And an oxyacid is going to have more than two capital letters. So the first one is still going to be hydrogen, but then the next part of it is going to be like a polyatomic ion from that sheet. So if you remember that sheet from earlier this year where it was like nitrate, phosphate, sulfate, and all of those, that's the polyatomic ion sheet that I'm talking about. And I'll post one probably whenever you do the worksheet for this lesson. So again, oxyacids, they have more than two capital letters. Hydrogen's going to be the first one, and then it's going to be a polyatomic ion. So if the polyatomic ion, you look it up on that sheet, if it ends in ATE, like 8, then you're going to change the ending of it to ic, and then just write acid after it. So this first one, for example, we've got HNO3. So H is going to let us know that it's an acid. It has more than two capital letters. It's got 3. So the first part is H, and the rest of this is this NO3. So I'm going to look up NO3 on my polyatomic ion sheet, and then I found that it is nitrate. So I'm going to take the ATE here, the 8 on the end, and I'm going to change it to ic. So now it is nitric, and then I add acid. So it's nitric acid. So again, it's H at the beginning, so we know that it's an acid. And then it's got a polyatomic ion here, this NO3. So NO3, I look it up on my polyatomic ion sheet, and I find that it's nitrate. So nitrate, I'm going to change the 8 to ic, and then add acid. So this is nitric acid. Okay, the next one, it says if the polyatomic ion ends in ite, so instead of 8, it's ite, you're going to change the ending of the root to OUS and then add acid. So, for example, here we've got HNO2. So H tells us at the beginning that it's going to be an acid, and then we've got NO2. So we look up NO2 on this polyatomic ion sheet, and we find that NO2 is actually nitrite, and it ends in this ITE. So nitrite, we're going to change the ending to OUS, and then add acid. So this is going to be nitrous acid. All right, so those are pretty easy. Naming them are pretty easy. So let's talk about bases now. So bases are kind of the opposite of acids. And all bases have the polyatomic ion hydroxide, or OH, in them. Okay, so all bases, they are going to taste bitter. If you've ever gotten soap in your mouth, it tastes very bitter. Or if you like eating soap, then you probably know that it tastes bitter. Bases that are dissolved in water, they feel slippery to the touch. Again, they form a salt in water if you react them with an acid. They conduct electricity. Some common things that are bases in your house, like soap. Milk, I believe, is slightly a base. On the extreme end, we've got things like Drano, which are sodium hydroxide that's going to eat away at stuff that's clogged in your sink. All right, so bases are going to produce hydroxide or OH minus ions when you put them into water, which is how they conduct electricity. All right, so now let's talk about how you would name a base. So the end of every base will have OH, or hydroxide, at the end of it. So for example, it'll be like CaOH2. It'll have OH in it at the end. To write the name of this base, all you have to do is write the name of the metal that's with it at the beginning, and then write hydroxide after it. It's really that easy. So for example, if you have NaOH, you know that it's a base because it has OH at the end, and then you just figure out what Na is, and you write Na's, which is sodium, and then you write hydroxide after it. So it's really that easy. All right, so the next one is going to be MgOH2. The 2 doesn't matter down here. It's just trying to offset the charges here. So we've got OH, which is hydroxide. So we know that it's a base. And then we've got Mg here. So we're going to figure out what Mg is. We're going to know that that's magnesium. So it's going to be MgOH. So magnesium hydroxide. And it's really that easy. All right, so that's pretty much it for this presentation. That was pretty quick, pretty easy. So if you have any questions, please let me know. Send me an email or comment on Google Classroom. I hope you're having a great day. Bye.